Welcome to today's web conference, US Azure Partner Community Call for November. I'd like to turn it over to your first presenter, Nick Johnson, National PTS for Microsoft. Nick, you now have the floor.
All right. Thank you, Kim, and thank you, everybody, for joining us today. We are very, very excited to have a full agenda. We've got some great speakers lined up. I actually got to hear about this topic several months ago at our Ignite conference, and as soon as I heard it, I thought, wow, that's going to be a fantastic topic to talk about with partners when the time is right, and now the time is right. And so we're going to talk about the advanced threat analytics today. We've also got somebody coming in to talk about some of the Pi updates. So if you're not familiar with Pi, it's our partner investment engine. So we've got some updates to share with you. We also want to share some resources with you. But before we dive into that, let me just go through a community roundup. These are some of the big announcements that have happened in the last days and weeks that obviously are very impactful to partners. We want you to be aware of these. First and foremost, very excited to talk about Azure and Red Hat and the support that's now been established for that. So if you've got customers out there that have said, you know, I'd really like to move my solution to Azure, but you don't support Red Hat, well, that has changed. So if you haven't spent any time on that, please go check that out. There's plenty of information out on Azure.com as well as if you search all across Microsoft.com. So we won't dive into that today. We will probably dedicate a session to that in the coming months just to be able to bring on some experts to show you more about how to engage with Red Hat on Azure. Just announced in this week, Azure Disk Encryption. So this is something you guys as partners and customers have been asking us for a long time. We're very, very excited to announce that both data disks and operating system disks are now in preview for Azure Disk Encryption. It ties together with the Azure Key Vault. Go check out the Azure blog for more information on that. And the last thing I want to remind you of is actually a post I put on our Yammer group a few weeks ago, but there's a tool that's now available. If you're doing Enterprise Mobility Suite, there's a demo setup that is now available to partners. And if you remember back a few months, I think it was August, we actually as a community had the lead program manager for this and had a sneak preview of it. And that is now available for all partners to use. So actually in the chat window for this, in your console for this call, I just posted a link to MicrosoftOfficeDemos.com. And when you go on OfficeDemos.com, you can log in as a partner, click the Resources tab. And on the Resources tab, if you scroll all the way to the bottom of the screen, on the left-hand side, you're going to see a link to Enterprise Mobility. When you click on that, you're going to see up on the sort of the center section of the screen some getting started guides, some demo guides. Check out that getting started guide. It's going to help you get a tenant provisioned to be able to do EMS demos. It's got some data pre-populated, some user scenarios pre-populated. There's going to be more coming in the coming months with a video that walks you through how to use the whole thing. But we know enterprise mobility is a very hot topic right now for a lot of customers. So this is a great tool that's going to help you get out to demoing and showing it to your customers faster. So again, if you missed any of that, go back and check out the post I put on Yammer a few weeks ago, and there's more information there. And with that, what I want to do now is introduce you to Charlene, and Charlene is one of our program folks who helps run the Pi program. And so without any further ado, let me turn it over to her to give us an update on where things are at.
Hi, I'm Charlene. It's nice to meet you guys at this meeting. The Pi program is run by Stephanie Martin, who's on a plane right now, so I'm filling in to help educate you guys on some of the Azure-related programs. Let's see, can we move to the next slide? Oh,
Go ahead and take over as presenter on the top center.
All right.
Perfect.
Okay. This is a slide of the handy links, and I want to let you know that this presentation is going to be posted on your Azure Yammer group, so you will have access to these links. But Pi stands for the Partner Investment Engine. It's money that Microsoft has available to you to utilize for marketing activities and a few deployment activities. So I'll go through the ones today that relate to you and that many of you qualify for these programs, and some of you may have heard of them already. And also at the end, or in this presentation, I've got a sneak peek of an upcoming program that will be released at the end of this month. You can always email Stephanie or myself at if you've got questions about the mechanics of the program, you can email Pi support. You can also email Stephanie or myself for any questions. I want to point out the external Yammer group, which I encourage all of you to join. This is updated constantly with decks about information about the programs, questions that people have, budgets every week are posted on Monday, and how much money is remaining in certain budgets, or if budgets get replenished, that all gets communicated over the Yammer group. Once a month, we've got office hours, which are recorded. We encourage you to attend in person so you can ask questions. We keep them really short so they won't take much time out of your day, 15 or 20 minutes. And you can always find those posted onto the Yammer site, the recording, if you didn't have a chance to listen to it. And we've got links here to some how-to guides on the mechanics of working with Pi. So I'd like to start off with our marketing programs. The first one I will talk about is the Cloud and Data Platform Partner-Led Immersions program. This is for partners who have been certified, are immersion certified, and if you would like to become immersion certified or learn more about it, there's a link at the bottom here, Microsoft Immersion at Microsoft.com, for further details about that and training. But in this program, partners can claim $500 of development funds for running an in-person immersive experience to a customer in CTM, CAM, EPG, or public if there is an associated opportunity in the PSX of $25,000. It even has ready-to-go content and training available, so it makes it really easy for partners that wish to run an immersive experience. The payout for this is $500, and you can do more than one event with no cap on the number of events that you do. And the program is to highlight Microsoft Azure, Enterprise Mobility Suite, Operations Management Suite, and SQL Server. These are in-person events that are done with the customer. And yeah, any additional requirements are just marketing funds for partners that drive in-person immersive experiences. For the next one, this is the Cloud Platform Practice Development. This program is open either to NSP partners or partners that are Azure Hero Maker partners. And if you are not an Azure Hero Maker partner and would like to learn more about becoming one, you can always email heromaker@microsoft.com. And this program provides marketing funds for the partners who wish to drive cloud platform marketing activities to build the cloud sales and pipeline for Enterprise Mobility Suites, Operation Management Suite, and Microsoft Azure. The nice one about this one is it encompasses a broad variety of activities that you can do with the customer. Advertising offline, advertising online, search engine advertising, search engine optimization, social media and marketing and communities, direct marketing, a telemarketing blitz, in-person events, digital events, and MEC events. And this has a maximum of 5,000 per partner. We still have 49% of the budget for this one available, so I encourage you to take advantage of it before the budget runs out. And I'm sorry, I forgot to mention on the previous program I just talked about, there's 52% of the budget available still for that one. So still a chunk of money in there to go after. So because you are part of the Azure community, you are the first to have a sneak peek into this new program that will launch on November 30th, so right after Thanksgiving. This program will be open to gold or silver cloud platform competency partners, which are many of you. The purpose of this program is to drive Azure Marketplace adoption and usage by scaling through the partners. So you've got the opportunity to influence the customers in ISV app review and purchase cycles using the Azure Marketplace as the concept review, the dev test, and the learning platform. So within the scope of this program, your role is to demo Azure Marketplace to customers after assessing the fit and doing use cases for the customer's workloads and helping with trials of ISV apps on AMP. This program provides $2,000 per event, and each customer can participate in up to 3 different events. So it's not by partner, it's by customer. These events just need to be completed by the end of February of this year. That one still has full budget because it hasn't gone live yet. So I encourage you to do that. And finally, in pilot and deployment programs, we've got one program that touches Azure, and this is the Microsoft Azure Assessments. Probably most of you are already familiar with this program because it's been around for a while, but we just got a huge budget increase a couple weeks ago. So we're now back up to 78% of the budget available. So there's plenty of money. I encourage you guys to go for it. This program is open to Azure Hero Maker partners, NSP partners, Gold and Silver Cloud Platform Competency partners, and it is for partner-led customer assessments that can lead to a minimum of 10 times the attributable Azure consumption. So a $2,000 engagement must lead to a minimum of a $20,000 Azure consumption. There is a cap of $2,000 per customer, but there's no cap per partner, so you can do this with as many customers as you would like. The customer segments for this one are CAM, CTM, public sector, all public sectors, and EPG. And the Azure consumption in this program must occur by June of next year, June of 2016, and the opportunity must include a minimum of $20,000 in Azure revenue. And that summarizes the PI programs that we've got available for you. If you've got any questions, I encourage you to type them in, and they will get relayed over to the Yammer site. And I also encourage you to join that Yammer site if you're not already on it and ask questions there. That's monitored many times throughout the day, and there's a lot of good discussions that go on there. So I encourage you to ask questions there. And I thank you. I'd like to hand this back over to Nick.
All right, Charlene, thank you so much for that. Great update, folks. There are funds available. Make sure you're taking advantage of those to help drive business in your space and with your customers. We don't want to leave any money on the table, that's for sure, so take advantage of that. I did post a link to that Yammer group that we mentioned into the chat window here. So if you have questions, you want to go follow up, find out about the update calls and that type of stuff, head on over to the Yammer group. That way all the folks who are involved in the program can answer your questions, and you can see each other's questions and learn from those as well. So with that, I want to switch gears a little bit and bring in Michael Dubinsky. Michael's a senior PM who focuses on our advanced threat analytics, and he's going to give us a little bit of a deeper dive into what it is and what it means for us going forward. So Michael, the floor is yours.
Thank you very much, Nick. Hi, everyone. So I'm a program manager or a product manager for Advanced Threat Analytics, which is a pretty new and exciting product from Microsoft. Actually came from an acquisition of an Israeli cybersecurity startup named Dorado. So we've all been with Microsoft for the last year since the acquisition, and we shipped ATA at the end of August, the general availability release. And during this slide deck, we'll discuss why did we build this technology, what's the value proposition of the technology, how it works, and then we have a really cool demo at the end of how an actual attack looks like on an Advanced Threat Analytics attack timeline once it's detected. So with that, let's start. So let's start with some statistics about how attacks nowadays look. So the first thing we know is that it takes a long time to detect attacks or to detect intruders inside the corporate networks. It actually takes more than 8 months since the moment the intruder gained access to the corporate network until the IT or the security teams actually know they're victims of an attack. So that's one thing. The second thing is that we know in most of the network intrusions, compromised user credentials are being used. And it makes perfect sense, because if you think about what's the purpose of the attackers, their goal is to try and steal some information, whether those are credit card numbers or company intellectual property or anything that they want to exfiltrate outside the company. They first need to gain access to that data. In order to gain access to the data, they need to somehow authenticate themselves and authorize themselves to gain access to the resources that hold that sensitive information. So it just makes perfect sense that compromised user credentials have to be used in order to be able to successfully execute an attack against a corporate network. Now, with that said, the cost of those advanced attacks is just enormous. So the $3.5 million, which is the average cost of data breach to a company, it's just the cost for the professional services to come in, to figure out the root cause, to remediate, to do the investigation phase, and then make sure that the attacker is no longer inside the corporate network. But depending on the data that is stolen, and the damage to the company may be much, much higher than that. So why does that happen? Why is the frequency and sophistication of the attacks is getting so much worse? Why do we see every other week in the news that there is another company that was compromised? So the first thing is the fact that credentials are being compromised. The fact we see many new tools being used by attackers today in order to be able to execute a privilege escalation attack, in order to be to execute credential theft attacks such as pass the hash and pass the ticket and a bunch of other attacks that we see today. And the second problem is that we see more and more attackers actually using legitimate IT tools rather than malware. So if the attacker is using, for example, sysinternals tools for their benefit, for the attacker's benefit, in order to run remote code or in order to escalate their privileges, those are just legitimate tools used for non-legitimate reasons. So now you're at a problem because you need to figure out what's the intent, whether the intent is of an IT person or a help desk person to try and troubleshoot a problem, or whether the intent is for an attacker to try and escalate their privileges or run some code remotely. And that's a big problem. And the last two things, which we already mentioned, we know they stay in the network for an average of 8 months. It actually gives the attackers a very long time to figure out what's going on inside their network, to figure out where the resource they want to attack are located, which users they can compromise, etc. So with that said, let's figure out the problem. Let's summarize the problem. So the traditional security tools, the problem is that they're complex. It takes a very long time to set up those tools. It takes a very long time to create the rules, to create the thresholds, to fine-tune everything. And then you're at the chicken and the egg problem. Either your security team invests its time into fine-tuning, creating the rules, creating the baselines to reduce the false positives, or if you don't invest the time in the complexity of the product, then you're prone to false positives. And we actually heard from customers that in real attack scenarios, they weren't able to detect those attacks, not because the existing tools didn't detect them, but because it was one event out of 1,000 that a security operations center of 2 people have to handle every day. So if you have one true positive out of 1,000 false positives, the chances are you're not going to be able to identify that attack in a timely manner. And that's where the 8 months number comes from. And eventually, the existing solutions are designed to protect the perimeter. So we're protecting from attackers coming in inside our network. But if they're already managed to gain access to the network, and it's not a question of if, but rather a question of when, because we see all those new techniques of spear phishing on social networks and frauds via emails and phishing attacks via emails and a bunch of new sophisticated attacks that we see around that space. The attackers eventually will be able to get access to the corporate network. The question is, what happens then? How can you detect the intruder when they're already inside the corporate network? How can you detect the intruder when they manage to gain access to one of the mobile phones of the employees, and that mobile phone then connects to the corporate network in order to synchronize its emails? So that's a big question. With that, I would like to introduce Microsoft Advanced Threat Analytics, which is an on-premise platform to identify advanced security attacks before they cause damage. Think about this concept, which is similar to how credit card companies monitor the behavior of the credit card holders. Take me, for example. I'm based in Israel, so my credit card company actually knows that because of how I behave based on my credit card, because they know I fuel my car in Tel Aviv, and they know I buy lunch in Tel Aviv, and they know I go out with my friends in Tel Aviv. So basically, they know I'm located in Tel Aviv, in Israel. And if at the same time someone is using my credit card in Brazil, in Rio de Janeiro, to buy groceries in the supermarket, that would get flagged as anomalous activity by the credit card company. Either they would block it automatically, or they would give me a call and say, hey, we have this anomalous activity on your credit card. Was that you? The answer would be, no, that wasn't me. And they will be able to block my credit card and make sure that the damages to the credit card company is in the single-digit dollars and not in the 1,000 or 100,000. So basically, by detecting this abnormal behavior, they can figure out there is a security breach in their platform or in my credit card and block that before that causes damage. So advanced threat analytics actually brings this concept to the corporate environment. Advanced threat analytics has this behavior analytics engine which monitors the behavior of the entities in the environment, of the users, of the computers, of the resources, of the different devices, and learns what a normal behavior is. Once it learned what's the normal behavior for that specific environment, it is able to flag abnormal behavior and to flag that to the Security Operations Center, which then are able to follow up on that abnormal behavior and figure out whether that's a breach, whether that's an attacker, or maybe just someone that some misconfiguration in the environment that may look abnormal just as an attack that is happening. So that's one side. But that's not the only detection engine we have with ATA. The second part is the detection for known attacks and issues, so the deterministic detection engine. We actually have, internally, we have a security research team that constantly look at how attacks are being executed, what tools are being used by the attackers, what techniques are being used by the attackers, and then we build this information into the product to be able to deterministically detect different attacks. So for example, pass the ticket attack. We don't need the entity to behave abnormally in order to detect pass the ticket attack. We can detect that in a very deterministic way and say we know that this specific authentication ticket has been stolen from device A and used on device B. So that's the deterministic detection engine. And those two detection engines combined is what we ship with ATA and what we call the advanced threat detection. So what are the benefits of ATA? The first thing is once you deploy it, you don't need to create any rules. You don't need to configure any thresholds, any baseline. Any information ATA needs, it learns and profiles for that specific environment over time. ATA actually leverages Active Directory network traffic and information collected from existing SIEM solutions in order to learn this information and to create its own automatic thresholds or rules. The second thing, the machine learning behavioral engine is constantly learning. So we're constantly updating what normal behavior for a specific organization looks like. So for example, in a scenario where there is an M&A event, so the behavior in the organization changes significantly because there are much more new users coming from a new environment. Or we deploy a new service, for example, that a lot of users access to, so their behavior changes. ATA would actually pick that up and wouldn't flag that as an abnormal behavior because it constantly learns and adapts to the behavior inside the organization. The third thing, and I'll show it in the demo, the simplicity of ATA. When you look at the console, you actually see a very Facebook-like feed of an attack timeline where every suspicious activity shows the who, the what, and when, and the detection happens in near real time. So from the moment you execute a pass the ticket attack to the moment it's detected, it actually takes a couple of minutes. And the last thing is the accuracy. So because ATA compares the profile of the entity not only to its own behavior, but also to behavior of other entities in the organization, we verify every suspicious activity before we actually say, hey, this is an abnormal behavior. You should look into that specific entity. So when we say that's an abnormal behavior, we verify that and cross-verify that with other entities in the organization in order to be sure of that. Some key features of ATA. So the first thing is the mobility support or the third-party operating system support. So for us, there are no agents. There is nothing we need to install on the client devices. And that means that to us, an Android phone or a Mac device or a Windows device is all the same. All of them need to authenticate, all of them need to authorize themselves in order to gain access to corporate resources, and once they do that, ATA picks up on that information and adds that to the behavior model. The second thing is the integration with SIEM solutions. So we know for a lot of customers, they already made a significant investment in their SIEM solutions, and they use that as a dashboard for the Security Operations Center, and they use that to collect a lot of information from their environment. So ATA has two-way integration with SIEM solutions. ATA can actually forward any information detected by ATA into any SIEM solution for the security operations team to look at the dashboard they're already used to and follow up on the investigation after they've seen the suspicious activity in the ATA console. The other side of this integration is for the SIEM solution to feed information already collected into ATA to enhance some of the detections. And the last thing is the deployment. So we'll go over how ATA actually works. But in terms of the deployment, we have a 7-minute YouTube video about how to deploy ATA. And the 7-minute video is actually the amount of time it takes to deploy ATA in a small environment. Obviously, in bigger and more complex environments, we'll need to plan for the deployment and figure out where we want to place the different components. But we do spend a lot of time in the deployment and how do we want to deploy ATA in the product team side so that for you it would be the easiest experience as possible. So let's look how ATA actually works. So the first thing, ATA relies on port mirroring. Once you deploy ATA, you configure port mirroring to copy all the network traffic going in and out of the domain controllers to the ATA components. And you have this functionality both in the physical switches and the virtual switches in your environment. So we support both physical and virtual infrastructure for the Active Directory. Once the port mirroring is configured, ATA analyzes the raw network traffic. And we use deep packet inspection technology we've developed, and we actually analyze the traffic up to the top level protocols. So when we look at the network traffic, we look at the Kerberos protocol, we look at the LDAP protocol, we look at the SMB protocol, all the top level protocols in order to understand how users behave in the network. And the fact is, since we look at the Active Directory traffic, which is the central source of authentication and authorization, we're actually seeing all the authentications being done inside the corporate network and all the authorizations being done against the different resources in the corporate network in this source of data. The other thing, ATA can also use, as mentioned, event information, event logs from the domain controllers, either via Windows Event Forwarding or via forwarding from the SIEM solution as an additional data source to enhance the information collected by the network traffic. So now that we have this network traffic information analyzed, ATA begins learning. We take all this network traffic and we build a behavior model for the entities in the organization. We look at how users behave, which computers do they use, which devices do they use, which resources do they access, which hours or time of day do they usually work on, and we feed all that information into the behavior model for ATA. The requirements of the behavior model is actually we need 1 month of learning, but this is a sliding window. So as I mentioned, ATA is constantly adapting its behavior model. So we use the last 30 days of activities in order to build the behavior model for the organization. And the actual machine learning algorithms we use in order to build this behavior model were developed inside the ATA product group by a very specialized team of data scientists that constantly look at this data and constantly come up with new ways to model this data in order to detect abnormal behavior. Once ATA learned what normal behavior looks like, then it can start detecting the abnormal behavior. But having said that, the deterministic detection engine, which is also part of the ATA, begins working from the first minute ATA is deployed. So for the deterministic detections, you can actually ATA can actually provide this value just after the installation. You don't have to wait for the abnormal behavior model to be built. In order to detect the abnormal behavior, we need this 30 days of sliding window, after which we know how normal behavior in the organization looks like, and we can start detecting abnormal behavior and identify suspicious activities. And again, as I mentioned, we have both a data science team which looks at the data and works in order to constantly update and build the normal behavior and the abnormal behavior detections. And we have the security research team which constantly looks at the new attack vectors, the new tools, and the new techniques being used by the attackers in order to provide the deterministic detection engine and to improve our detections there and come up with new detections in the deterministic detection engine. So once ATA has detected that a suspicious activity has occurred, it will alert on a simple and functional attack timeline. In the attack timeline, each suspicious activity will have the profile of the entities involved. It will have exactly the information, exactly what happened, how it happened, and it will provide you with access to their own network activities, which you can use for further investigation. Now also, for each suspicious activity, we provide recommendations and investigation steps in order to figure out exactly what happened, what investigation steps you should follow for the user or for the device that was compromised, and how can you remediate this issue as quickly as possible. In terms of the detection, so ATA has 3 flavors of suspicious activities. The first flavor of suspicious activity is the abnormal behavior. So the abnormal behavior is very useful for detecting lateral movement, is very useful for detecting password sharing, and very useful for detecting unknown threats. So tools and techniques we're not aware of yet, and new tools that just came up, that attack teams just came up with. And that's based on the machine learning algorithms and the behavior model. The second flavor of attacks we have is the malicious attacks detected using the deterministic detection engine. So in here we have a partial list of what ATA supports in the general availability release, and each update of ATA will contain updates to that model, to the deterministic detection, and the abnormal behavior detection. So the deterministic detection, using the deterministic detection engine, we can actually detect attacks such as pass the ticket, pass the hash, overpass the hash, privilege escalation attacks, brute force attacks, reconnaissance attack, etc. And the last flavor of attacks we have, or not necessarily attacks, but rather security issues and risks, are things like weak protocols, exposing passwords in clear text over the wire. So those are not attacks per se, but the reason we detect them is because if we see sensitive account credentials exposed over the wire in plain text, that means the attackers can see them as well. And if the attackers can see them, then it's just giving them privileged accounts on a silver plate. They don't need to work very hard to escalate their privileges, right? So we don't want that to happen to our customers, and that's why we would alert our customers on every security issue of weak protocols and other vulnerabilities that we detect. So how does the ATA topology look like? ATA actually has 2 components, the gateway and the center. The gateway component is kind of like the ATA probe. It listens to the network traffic. That's the port, the destination of the port mirroring you configure. It also listens to the events coming either from the SIEM solution or from the domain controllers configured with Windows Event Forwarding to the ATA gateway. And once it analyzes this traffic, it sends this information to the ATA center. The ATA center is kind of like the brain of ATA. That's where we have the machine learning algorithm, that's where we have the database, and that's where we have all the detections running on the data provided by the gateways and surfaced into the suspicious activity user interface. So in terms of the gateway, we mentioned the main goal of the gateway is to capture and analyze the network traffic and the events. Each ATA gateway supports multiple domain controllers from multiple domains in the same forest. And one of the other things that the ATA gateway does is entity resolution. So entity resolution is actually a patent pending technology by us, the ATA team, where we look at the entity we see in the network traffic. We look at the information about the entity, so things like the IP address and the username, and we resolve that information to actual objects. So for example, if we see an IP address as the source of a specific network traffic, we would go and resolve that IP address to the device's name. And after we resolve that to the device's name, we actually try to resolve that to the relevant Active Directory object, so whether that's a computer account. And that's the reason when you'll see the user interface in the demo in a couple of minutes, that every single object we have in ATA is actually an entity profile. We don't have events with IP addresses and strings representing usernames. Every object in ATA actually has a profile, and all network activities that we see in a specific gateway are correlated to the relevant entity in the ATA database. And the reason we can do that is that specific entity resolution engine. So once the gateway has received the network traffic or the event, resolved all the entities inside that specific network packet or event, it transfers the information to the ATA center. The ATA center, in turn, stores that configuration in the database. It also provides a central configuration repository for all the ATA gateways. So all the configuration of the gateways deployed in the environment is managed by the ATA center. And then it runs the detection engine, which detects the suspicious activities and builds the normal behavior profile, and then detects the abnormal behavior of the different entities in the organization. Each ATA center can support multiple gateways, so we have kind of a many-to-many relationship. We have each gateway supporting multiple domain controllers, each center supporting multiple gateways, so eventually we cover the entire forest. The deployment boundary of ATA is an Active Directory forest. And eventually the ATA center also provides with the web management interface. So with that, let me share my screen and switch to the ATA console for the demo. Great. So once I've logged into the ATA console, what I see here is the attack timeline. On the attack timeline, I have suspicious activities on listed in the order they were in terms of time. So the first suspicious activity we have here is reconnaissance using account enumeration. So usually what happens when an attacker first gains access to a corporate environment, they don't know which users exist, which users don't, which devices exist, what can they use for their benefit. So they start with the reconnaissance phase. And we have several detections around that reconnaissance phase, and specifically the one we see here is the reconnaissance using account enumeration, where an attacker tries to guess usernames they can later use for different purposes inside the organization. Usually it happens with a dictionary. So in this example, we see that a suspicious account enumeration activity using Kerberos protocol originating from a specific entity on which when I hover I can actually see the profile, the mini profile of that entity. And we see that the attacker performed a total of 105 guess attempts for account names. Three guess attempts matched existing account names. When we look at the glance view, we see all the dictionaries that were used, all the usernames that were used and weren't successful, and we see the accounts that were successfully guessed. In this example, we see 3 accounts: Idan's account, the administrator account, and my account, which was the username for which was successfully guessed as part of this attack. Moving further in the attack timeline, we see that a brute force attack using LDAP simple bind was executed against Michael's Dubinsky account from the external vendor terminal server, and the account was successfully guessed. And again, we see here that the attacked account was my account, and the potential guess, again, my account was successfully guessed. In this example, it's a vertical brute force where we have multiple passwords against the same account. We also have a flavor of horizontal brute force where we have multiple accounts being guessed with multiple passwords. So that's the more common flavor of brute force attacks, where the attacker says, I don't care which account, I just want to guess the password of one of the accounts in the environment, which I can then use in order to perform some additional activities. Moving further in terms of time, we see that Michael Dubinsky started to exhibit abnormal behavior. Abnormal behavior means that he was performing activities that were not seen in the last month, and also not in accordance with the activities of other accounts in the organization. So basically, we took the behavior of Michael Dubinsky, we compared that to its own behavior and to the behavior of other entities in the organization, and we came to the conclusion that those activities were abnormal. Which activities were abnormal? We actually provide the information here. Michael performed interactive login from 4 abnormal workstations, interactive login from 2 abnormal servers, and requested access to 5 abnormal resources. And he also exceeded the normal amount of working hours, specifically Edward Snowden's case. For each suspicious activity, I can also switch to the details view, and then I can see all the information, exactly which device was used to access which resource, and what are the normal devices in black and the abnormal devices in red. So going back to the attack timeline, we know now that Michael Dubinsky's account was compromised. We can actually correlate the attacks that happened on the same account from the same source device, so that looks as part of the same campaign. And once Michael's account was compromised, the next thing we see is the administrator's Kerberos ticket were stolen from the shared admin server to the external vendor terminal server, and they were used to access the CIFS resource on DC01. We can actually go ahead and correlate those two suspicious activities. If I'm looking at the abnormal computers, I can actually see that the shared admin server was accessed by Michael just 1 minute before Pass the Ticket attack was executed from the exact same server. So now I have a lot of suspicion on Michael's account, and I also have suspicion on the external vendor terminal server. So I can switch to the profile view of that specific entity, and in the profile view, I have some pretty useful information like what was the last password change, what were the IP addresses that were used by that specific device, in which sites was that specific device located. In this example, I just don't have any sites in my Active Directory environment. And then I can switch to the suspicious activities view involving that specific device, or from that specific device's context. And then I see the attack timeline from the context of the external vendor terminal server. There I can see that after the Pass the Ticket attack was executed, so basically our attacker managed to figure out that Michael's account exists in the environment, managed to use Michael's account to brute force Michael's password, use Michael's account in order to perform lateral movement and gain access to the shared admin server, on which he was able to dump the shared the administrator's Kerberos ticket and steal that to the external vendor terminal server, which he then used to access the CIFS resource on DC01. The last thing we see is that a remote execution attack was detected, again by the administrator, from the external vendor terminal server just 2 minutes after the Kerberos ticket was stolen. So again, based on this attack timeline, we can actually correlate between the two suspicious activities. And looking at the details of that specific suspicious activity, I can actually see that the PS-exec service was created, just an example of legitimate IT tools used for malicious purposes, that it was created successfully with that specific command line. So in this attack example, that's kind of game over for the environment, because the attacker managed to gain control of the domain control. So basically they have now all the information of all the users and all the passwords in the organization. But in terms of ATN remediation, the customer could have actually stopped the attack at any single part of the attacker kill chain, as we see here, which is a very common kill chain. So either on the reconnaissance phase, the brute force phase, or the abnormal behavior phase are all good phases detected by ATA, where the customer can remediate that and still make it on time before the attacker manages to gain access to sensitive resources and exfiltrate that information from the corporate network. With that said, I'm done with the demo, so I'll be more than happy to answer any questions that you may have regarding ATA. Nick will help me with that. Nick, any questions?
Yeah, we did have some questions come in. First one is the database SQL based, or what is it built on?
No, we actually use MongoDB database. And the reason for that, we need document database because there is no structure to network traffic. So we can't use structured database in order to store network activities.
Okay, great. As far as doing like demos of this, what's a good tip for doing demos? Because obviously we don't want to necessarily install this in demo against live production instances. So what's a good tip for that?
So actually the demo environment we use is just a couple of VMs. We created like a domain controller VM, two member servers or client VMs, and then a single ATA for the single VM for the center and the gateway on the same box. And once you've simulated the suspicious activity and you have the console populated, then you can just use the ATA center box without the gateway service running or without the domain controllers to just demo the user interface.
Excellent. And you can do all that actually in an Azure virtual network with VMs there as well, right?
You could have the center on Azure. Currently, we do not support domain controllers on IaaS, but that will change in very soon.
Okay, so that is coming very quickly. Thank you for that. Now, what happens when the initial learning starts to roll out and the attacker is already inside the network? Is it going to sort of see that attacker as already behaving normally, or is it going to figure that out somehow?
No, so during the learning phase, we actually exclude the extra noisy actors. So those could be attackers, those could be some other scenarios, but we exclude them from the normal behavior model. And then when we rerun the model, if they still behave the same way, we would actually detect that as abnormal behavior.
Okay, perfect. Does Advanced Threat Analytics work with Intune as far as doing mobile devices and things like that?
No, we don't have integration with Intune. But having said that, ATA can, as I mentioned, can forward the information, detected information, either via syslog or via email. And it, in any case, it surfaces the detections to the event log. So you, if you want to build some workflow based on the detection, you can do that based on the event log surfaced on the ATA center.
That's perfect. Thank you. And one last question that just popped up, I believe. Oh, no, we actually answered that one. So that is the end of the questions. Folks, if you have any other questions, feel free to put them into the chat window down at the messages button at the bottom of your console. And with that, though, I will thank you for attending this month. You're going to get a survey link here in just a second, and just a special note. I want to appreciate everybody who's already filled out surveys in the past. When you fill it out, focus on the comment section if you wouldn't mind today. Tell us a couple of things. Tell us what are topics you'd like to see in the future. We want this community time to be valuable to you. Secondly, tell us how you like to learn. So you're going to see a renewed emphasis in the next several months from Microsoft on helping partners learn and keep up with everything that's new. Do you like to learn via community calls? Is it online videos? Is it classroom training? Is it 5-minute stuff? Is it 4-hour stuff? Just kind of give us your take on how do you prefer to learn? How do you like to build learning into your organization? That's going to help us inform decisions about how we service you guys as partners best going forward. So anything you can do, that will be really good. And I don't have any other questions that came in. So Michael, thank you so much for the presentation. Folks, we will post the slide deck and the recording here out to our Yammer group very quickly. And that's all I have. So I'm going to turn it back over to Kim to close us out.
Great. Thank you, Nick. Ladies and gentlemen, your feedback is important. We hope that you found today's information helpful. Please take a few minutes to let us know by completing a short survey. Please click on the messages button to find a link to the survey. And you can access the web conference recording via a link that will be delivered within 72 hours post-conference, as well as the Yammer site. And I'd like to extend a big thank you to our presenters, Nick, Charlene, and Michael. This concludes today's web conference. You may now